All right. Welcome back. That's the problem with free stuffs. If you don't pay for it, it always the service is always not that good. So every 40 minutes, it goes off, but we can always reconnect back and continue with the lectures. Hopefully, your school administration will do the subscription for the lecturers so that we can have a free flow of lectures, hopefully. So let's continue from where we stopped. So we were talking, we have this equation that we expanded. We have something like this, if you were following 6p. And as I said, these are very basic, but I needed to do it so that everyone can be on the same boat. Experience has dictated that some of people, some of the students, they come with some math deficiency. So I need to do this refresher course. Next week we can start function from there. We do derivative calculus and all this stuff like that. All right. So we have 3 minus 3p. This is what we had before the minus 7 over 6 p minus 7 over 3. So when we expand, after expanding the bracket, this is what we will have. Hopefully, if we are taking the notes, the question is already there. So we expanded the bracket, then we have this. So after expanding the bracket, the next step, remember always the first step is to identify what kind of equation you are trying to solve. And we identify this as a linear equation because the highest power that a variable has there is 1, so it's linear. We have a bracket within the equation. Always in maths, expand the brackets to see what it will give you. So after the expansion of brackets, so we have to collect the like terms. We have the 6p here, p, we have p, then here we have 3p, and then we have this. So we make sure that we collect the like terms on the one side. I like to transfer the variables on the left-hand side, but you can also do it on the left-hand side. It depends on your choice. So we see this is a constant, and we know that this is a variable. This is a variable. This is a variable, and this is a variable. So here we have a constant. So what we will do, we transfer all the constant to the left-hand side of the equation, and we transfer all the variables to the left-hand side of the equation, and we transfer all the constants to the right-hand side of the equation. So meaning that this has to go, and this has to go as well. And remember, which is when we did it in high school, if a variable or a constant is transferring to the other side of the equation, it has to change sign. So these ones will go to this direction, and their signs, we have to change them. So if we do the transfers, this will be 6p minus p. This will transfer. Remember, it's minus, the signature, or the sign rather, is minus. So if it's transferring, crossing this equals to sign. If it's transferring and crossing this equals to sign, then we have to change the sign. We have to change the sign. So here it will be plus 3p. Then here, then we have our equals to sign. We will have this 3 will come down as 3. Oh, we have to transfer this one as well. So we are not done yet transferring. We transfer this one has to go as well. So this one has to go also. The sign is minus. So when it's crossing the equal to sign, it will be positive. So it will be plus 7 over 6 P equals to, then we can write our constants now. Everything is being transferred to the other side of the equation. 3 minus 7 over 3. So we have this constant, it has to come here. The sign is positive, so it will be negative when it's transferring, changing the, when it's transferring from one side to another, it will minus 3 over 2. So we have seen that what we can do. Now here on this side, we have all the variables. On this other side, we have the constants. So we identify what type of equation it is. We said it's linear. We expanded the bracket. That was the second step. The third step, we collect the like terms. Constants all goes to the left hand side of the equation, or sorry, to the right side of right side. These are the constant to the right side, right hand side of the equation. Here we have the left hand side of the equation. So we put the variables there. So if you see this, we want to add this, and add it. But the problem comes when we have the denominator, or in another word, when we have fraction. We cannot add it like this. There's a fraction there, so it causes problem for us. But we can change all of these to fraction by dividing them by 1, because 3p divided by 1 is still 3p, nothing changed. We can divide this by 1. So if you looked at it properly, you will see that we have 1 here, 1 here, 1 here, 6, 1, 3, 2. So these numbers that are in the bottom of the fraction, we call it denominators. So when you have something like this, if you want to solve it, because here, remember, the goal is to find the value, the numerical value of P. This is the goal. This is what we are searching. If we want to solve this, we will have to find what we call the lowest common denominator. So what we've looked for a number whereby 6, 3, 2, and all this one can go without a remainder, but should be the lowest one. So we know that then 6 will be the answer. Because here, this 6 can go into here without, it can go here exactly without a remainder. 1 can go here exactly, 1 can go here exactly, this one can go here exactly, this one can go here exactly, 3 exactly, 2 exactly. Someone might say 12, and it's true, because all of them can go into 12 without perfectly, without no remainder. But the problem is we are looking for the lowest one. We are looking for the lowest one. All of these 1, 2, 3, 4, 5, 6, 7, all of them can go into 12 without remainder. They can also go into 6 without remainder, but we are taking the lowest one. That's why we call lowest common denominator. So if we know this one, then we will use this 6 to multiply the left-hand side of the equation with it, and we use it also to multiply the right-hand side of the equation. Why are we doing this? Because we want to get rid of this 6, 3, and 2. So we will be able to get it, and then we will have an equation without fraction. We will see it as we go on. So let's take this 6 and multiply it by here and here. So this will be 6 into 6p. This 6p is this one, minus p plus 3p plus 7 over 6p. What I'm in this bracket is just these numbers I brought, because we are multiplying the left side of the equation and the right side of the equation by 6. And the goal, why are we doing that? is to make sure that we get rid of this fraction or denominators. And we choose 6 instead of 12 because this is the lowest one. So we go on. And it's equals to, then we take 6 also and multiply it by total. What is here total? This will be 3 minus 7 over 3 minus 3 over 2. So we have this. We have this. So if you looked at it, this 6 times 6p, it will give you 36p. 6 times minus p, it will give you minus 6p. 6 times plus 3p, it will give you 18p. 6 times plus 7 over 6, 6 times plus 7p over 6 will give you 6 over 7, 6 times 7p over 6. We have that. Remember, we are expanding the bracket again. We always expand the bracket. So 6 times 3, you come to the right hand side of the equation, you expand it as well. 6 times 3, it will give us 18. So 6 times minus 7 over 3, it will give us, we can have something like this, 6 minus 6, then this. I can go on and do this and solve it, but I want us to follow step by step. Minus 6, this minus is this one, this minus is this one, times 3 over 2. So we have this. So here what we will do, we have this is okay, this is okay, this is okay. Here is what, we all know how we got this. So this and this, we will cancel them out. We will cancel this out and cancel this out. It will be left with only 7p. Now this problem of 6 is been solved. 18 is okay, minus 6 times 7 over 3. So this will, here is 1, into here is 2 times. So at the end of the day, it will be 2 times 7, then we will have 14 here. So we have here also minus 6 times 3 over 2. Here is 1, into here 3 times. So this 3 times this will give us 9. So now we have an equation without no fraction. So I will just copy this to the next slide. We continue working there. So we will have something like this, new slide. So we will have 36p minus 6p plus 18p plus 7p is a continuation of what we were doing in the previous slide. 7p equals to 18 minus 14. Hopefully everyone knows how the 14 came about. This 14 here is the product of 2 times 7. Then you'll have this 14. Then we have 9. And this 9 is the product of what? This 3 times this 3. We have that one, of 9. So now we have a new equation after identifying, expanding the bracket, looking for the lowest common denominator. Then we have an equation without no fraction. If you look at the original equation, compare with this is easier to solve. So we did some manipulation on the original equation to come here. So let's look at this. So we add all of this. We add all of this. If you look at here, we have all the constants here, and we have all the variables here. So it's very simple now to solve this equation. Remember, our goal is to find the numerical value of P. So 36P minus 6P plus 18P plus 7P, it will give you what? 55P. You can confirm it, which is equals to 18 minus 14 minus 9 will give you minus 5. Remember, our goal here is to find the value of P. So how can we find the value of P? Or we want to make the P the subject of formula in other mathematical language. We want to make P the subject of the formula. Or in another word, plain English, we want to make sure that P stands alone. It's very simple. So what we will do, we will divide both sides by the equation by 55. By 55. So divide both sides by 55. Now, what we will do, we cancel these things. So at the end of the day, this means equivalently, you will see this in your book. Then P equals to minus 5 over 55. Now, this equation is solved. This is what we mean by solving equation. This was a linear equation. We can go back. Okay, the first slide was, we missed that one. The connection went off. So initially it was a linear equation and we identified, and there was some brackets. We expand those brackets. We make use of some lowest common denominators. Then here we are, we find the value of P. So solving an equation meaning that to find the value of the variable. In this example, P is the variable and its value is what? Minus 5 over 55. One can even go further and reduce this because 5 into here is 1, into 55 is 11 times. So it will be minus 1 over 11 as the P value. So from there, I want to talk about, since we are going to be dealing with some fractions, there are some mathematical rules that I want us to talk about that you should always observe when you are dealing with fractions. So what is this rule about? What is this rule? So the first rule is this. You can never, let's say that we have a fraction like A over B. In mathematics, B can never be equals to 0. Because so far we don't have a solution for this. If you take your calculator, take any number and divide it by 0, for example, 5 over 0, just check it what your calculator will show to you. You cannot divide any number by 0. What it will show you normally if you try this, it will say maths error. You can try it now or after the class. So when you have a fraction, we have to be very careful. So because if A equals over this, we call this undefined. You cannot go further than this. You cannot. So let's say that we have a fraction like this, like Z over Z minus 5. So this is a fraction. And why is it called a fraction? We have a variable, we have a term here. We have a term here divided, they are separated by a division line. So we call it a fraction. So here, Z minus 5, this denominator can never be equals to 0. Why? Because there is no way you can solve it. So when you are dealing with fraction, this denominator that is here, the term below the fraction, can never be equals to 0. So you will come across with these things. So when you have a fraction, the first thing that should come to your mind is to say that denominator, whatever is here, should never be equals to 0. So for example, when we solve this, when we say minus 5 equals to 0, so the value, we want to find the value of x. So it will be z, not x, z, sorry. So z equals to 0 plus 5. So z equals to 5. So if you substitute this 5 into this fraction, let's see what will happen. It will be 5, because z is 5, 5 over 5 minus 5. So then we will have something like 5 over 0. So this, you cannot go further. This is where you can stop. You cannot go further than this. You cannot go further than this. So here you stop, you said, x should not be equals to 5. Why do you say x should not? This sign means not equals to. When you see this anywhere, I mean not equals to. So we are saying z should not be equals to 5, because when z is equals to 5, it will make this denominator 0. And when it is 0, we cannot solve that problem. This is some of the rules that we should observe, or we should pay attention to when we are dealing with fractions. Why is it? Well, we don't know, but it's a rule that we should observe, especially when we are dealing with fractions. So let's try to look at another equation. Remember, today our topic is solving equation. I'm reminding you, solving equations. So let's look at another equation, another example. So before we end the class, I would like to also, because these are mathematical, so maybe we can do some real life application whereby equations are used to solve business problem. Maybe that can give you some motivation to like the course, hopefully. So let's look at another equation here. It says z over z minus 5 plus 1 over 3 equals to minus 5 over z minus 5. We have this equation, as I always tell you. First, try to identify what kind of equation you are dealing with. It's key, it's important, especially when it comes to quadratic equation. So far, we have been looking at linear equation. First, how do you know that this is linear, this is quadratic or system of equations? We looked at the highest power that a variable has within that equation. So let's identify our variables. Let's try to identify our variables. This is x, this is our variable, z rather. I'm sorry, I'm so used to x. So this is z, our variable. We have z also in the denominator as our variable. On the other side of the equation.
Hello, Mr. Ture.
Sorry?
Hello, Mr. Ture.
Yes?
That one, I think it should be minus 5 over 5 minus z.
No, I detected that there is a problem in the book.
Okay.
Yeah, thanks. You have
All
been
right,
reading.
thank you.
Someone has been reading. Yeah. So there is a book. If you go, let me see. If you go by the book, there was an error with the textbook, the material I sent to you. Yes, so I changed it. Because if you go on to try to solve it, it will even confuse you more with the book.
Oh, okay.
There was an error, you understand? All right.
Oh, okay.
So you can change that in the textbook. They are human beings, you know, if professors can make mistakes, so it's normal. So let's go on and try to solve this. And first of all, I always tell you, let's try to identify what kind of equation we are dealing with. And if you looked at this to identify the kind of equation we are dealing with, first we have to identify the highest power a variable is having within an equation. So we have our variables here, z, 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 you understand? They don't have any power, but as I said, if there is no power written on top of a variable, you can assume that it's 1, 1, and 1. So if we looked at this equation, the highest power there is what? It's 1. And as I said, when the equation, the highest power within an equation is 1, then we classify that equation as what? Linear. So now that we identify this as linear equation, now we have to find a way to solve it. So if you looked at it, always, sometimes there will be a bracket. If there's a bracket, you expand. Luckily, life is easy. If they make life easier for us, there is no bracket here that we can expand. So what we can do now, we collect the like terms. Collecting the like term is subjective. Some people, for myself, I put the variables on the left-hand side of the equation, and I put the constants on the right-hand side of the equation. So let's go on and collect the like terms. So if you looked at it, look at the equation very well. This and these are like terms. And this we can classify it as a constant. Or these two are variables. We can, though it's having some constant in the denominator, but that's the best way to solve it. So what we will do here, this we will transfer it to this side of the equation. We transfer this to the other side of the equation. So we will do that in the step 2. So we will have what? Z over z minus 5 plus 5 over z minus 5 equals to minus 1 over 3. So now we have this. How do we go about and solve this? Remember, we are having fractions here. How the goal now, always remember, when we are solving equation, the goal is always to find the numerical value. Whatever we are doing, we are working towards finding what is z, if that's the variable in that, within that equation. So no, if life was easier like this, z plus 5 equals to minus 1, we can just bring this here. Unfortunately, we have these fractions here. And when you have fractions and you want to get rid of them, what you have to do, remember, lowest common denominator. Here we have a number mixed with variables. So what you will do, remember this and this, they are the same. And we have this. So your LCD will be this multiplied by this. So it will be 3 into z minus 5. So if we use this and multiply it across the equation, or we use it to multiply on the left-hand side of the equation and the right-hand side of the equation, we will get rid of this denominator, or the numbers that are below the fraction, which are z minus 5, 3. We will use this and multiply by this. We use this and multiply by this. We use this and multiply by this. Then we will get rid of the denominators. So let's go on and do that. So we will have something like this, 3. We use this lowest common denominator. I hope everyone understands how I got this. It's just this 3 because this is, we are trying to get rid of these things. So to do that one, this and this one and this one are the same. We are running out of time again, but I will still come back. I think that lectures is ending 7:30, right? All right. So when it runs out, I will log in again, and you can log in as well. Then we continue with the lectures. All right, so we multiplied this across the equation. So this will be 3 into 2 minus 5 times this term, z over z minus 5, plus this plus you bring it, then we multiply it by this one again, 5 over z minus 5. So it will be, please remember this is numbering before you mix it, please. This will be 3 in bracket z minus 5 times 5 over z minus 5 equals to, we take this lowest common denominator again and multiply, because whatever you do on one side of the equation, you have to do it on the other side of the equation. That's why we call it equation. Everything you do should be in tandem, in balance. Minus 5 times minus 1 over 3. So we have this. Now we can get rid of this, because this was, they were a problem. They were a problem now, but we can easily get rid of them by using this. So what we will do, this will go off. We cancel. This will go off. This will go off. So you see that we have get rid of the denominator. So we can have a very nice equation that we can easily solve. So we will continue to the next slide. Then we will have something like this. Let's go back. So it will be 3z. We will have it. So we have something like this, 3z. How did we get that? We cancel this 3 times this. This is 1, this is 1. So it's 3z plus, we cancel this. So this will be 15. Okay. Let's see, it's like we mix something. Okay, and we have, this will be 15. Is it plus? Okay, this will be 15. Oh, okay. Okay, so we go on, we are still on track. This will be 15 equals to, we cancel this and this. So this will be z minus 5. So it will be z minus 5. So we have this. I hope everyone is following. We go back. This 3z is what we have here. Then the 15, we cancel this 3 times 5. We have the 15. That's what we have here. Actually, it should be plus 15, not minus. So here we cancel this, so it will be z minus 5, but it should be in minus, we have this. So now we are here. So still now we have to do some arrangement. This is plus 15 equals to, This is minus z. This is plus 5. So we have this and this as like terms. We have this and this as like terms. These are variables, variable, constant, constant. This comes here. Say wants to speak.
Yes, sir. I just want to ask, how do you have 32? I'm sorry to ask though, because you said...
No, it's okay. What is the question?
How do you have 32?
No, it's 3z. 3z.
3z.
It's 3, it's not 32, 3z.
Very good, okay.
All right. So we have, this is z, please.
Okay.
We are writing on the whiteboard with a mouse, which is extremely difficult for us. That's why the speed is slow, and so we are using mouse to do this. We are not typing. So it's z, please. All right, so let's go on. We have this minus z, and it's something like that. So this will come here. This will be 3z. It's coming here. It will be, let's say, plus z. And we will have 5 minus 15. So we'll have 4z over minus 10. So at the end of the day, the goal, as I always said, is to find the numerical value of the variable. So to do that, we divide both sides by 4. Then z will be something like this, over 4. You can go further if you want to simplify it, because we have a number that can go into 10 and 4 at the same time without any remainder. So that is 2, 2 here is 5, here 2 times. So this is the simplest form, unless you want to express it in decimals. So we have this as solved. So before we end the class, let's take a real life application of some of the problems we can use in production process to solve some of the business problems as well. So for example, let's talk about the cost that is involved in producing a good. Cost. This is another example, but a real life example, cost of production. So if the materials I shared with you people is having this example, let me see. It's okay. I'm sharing the screen with you people.
Hello. Hello, Mr. Toure.
Go on, please.
Yes, this is Abdullahi.
Okay, go on with the question, please.
Yes, yeah, I was just wondering if I can have those materials, because I don't think I'm having them.
Okay, I talked to, if you know anyone, I share the materials within the group. So in the WhatsApp group, yeah, I think it was yesterday or 2 days back, they can help you out with it, please. Do you know anyone in the group?
I'm afraid not.
Okay, and just drop your, okay, that will be public, and your number, you can call me. I think you have my number. Then I will add you to the group.
Yes. Okay, so can I have it, please?
Yeah, okay. You don't have it?